This is Miss Mo. This is about 12.2. 12.2 is pretty small. I went ahead and deleted some problems. You're welcome. Okay, so first thing that we need to know is when it comes to triangles, the largest angle has the largest side across from it. And then the smallest angle has the smallest side across from it. Okay, and then the middle side has the middle angle across from it. It says, if possible, construct a triangle that has 3 segments, A, B, and C, this long, shown here as its sides. If not possible, explain why not. Okay, so B is the shortest side. So that means the letter B should be across from the shortest angle or the smallest angle. Okay, let's check it out. If we look at C, our side B is across from this angle. Okay, but this is supposed to be the smallest angle because B is the shortest side. But if you look at these other 3 angles, they all look the same. But angle B is supposed to be the shortest. So this one's out because all the angles are equal. And B is supposed to be the smallest angle. Okay, let's check out this sucker. This says that B should be the shortest or smallest angle. So here's my side B. And across from it, yep, that looks like the smallest angle in the triangle. Okay, well, let's check it. Let's look for the longest piece. The longest side is not B or C. It looks like it's A. So, opposite the A should be our biggest side. Let's check. Opposite our A should be our biggest angle. And this angle looks pretty big. It definitely looks bigger than this little B angle. Okay, let's see what C is. Side C has an angle across that looks like this. So the question is B the smallest angle? And it looks like it's smaller than these other 2. And is A the biggest angle? And it looks like it's bigger than these other 2. Okay, if we look at this first answer choice, okay, B is supposed to be our smallest angle, but if you look across from B, it looks like these 2 base angles are equal. They look like they're the same size, but they're not supposed to be. B is supposed to be the smallest angle. So A's out because it looks like B is an equal angle. It's the same as the angle to the right. Okay, answer choice B is the answer because the angle across from side B is the smallest angle. The angle across from A is the biggest angle. Yay, okay. Let's keep going. Okay, the next thing, we need to remind ourselves that included means in between. So, let's say I'm looking at this picture right here. Okay, and they give us 2.1 is AB and 3.1 is AC. Those are the 2 sides they give us. The included angle is not the angle out here, it's the angle in between the 2 sides. So this is an included angle, this angle A. Okay, if I look at this next picture, it's an example of an included side. So an included side means they give you 2 angles and the side that connects one to the other is the included side. Okay, let's go over this homework problem. It says a triangle. We need to draw a triangle with angles measuring 60, 70, and an included side of 8 inches. Okay, so that means we're given two angles, and the side in between it needs to be 8. So it's kind of like we're drawing this picture with 60 on one angle, 70 on the other, and 8 in between. So let's go ahead and cross out the answer choices that don't look like the 8 is in between. Well, A's out because the 8 is supposed to be in between those two angles. So A's out. B, it looks like that 8 is in between the two angles. C, the 8 is in between the two angles. D, the 8 is not in between. So it's supposed to be in between. And A and D are out. Okay, the next thing that we need to remember is your biggest angle. Well, okay, the next thing we need to remember is just kind of common sense. If 60 is this sucker, then 70 is a little bit bigger. Yeah. So if this huge angle is 70, 60 is smaller than that. Let's remember that, okay? So which angle does it look like is bigger? Because it needs to be the 70. So let's check out this. Part B, it looks like the 60-degree angle is this, and the 70 is that. Okay, so in this picture of the green and the red, look how the tilt of the line, it doesn't fall down as hard. It's not as low. So whatever the bigger angle is should be less steep. It should not be steep. It should be less steep, almost up and down. So when we're looking at these two pictures of B and C, the bigger angle should be tilted higher. Okay, well, let's see here. You can't really tell. But if you look at how fat these guys are, this 70 degrees should be fatter. And if you look at the way it tilts, this 60-degree line and this 70-degree line, the 60-degree line is lower down. This 70-degree is higher up. So, when we're talking about angles, 60 degrees, the line is lower, whereas 70 degrees would be a little higher. Okay, so this 70, his line is tilted, it's less steep, it's more straight. And this left-hand line, it falls down more. So since this left-hand line falls down more than the right hand, then it's the 60 degrees. So the answer is B. So that one's kind of hard. You might have to get a piece of paper and trace the triangle over your computer screen and then look at the piece of paper, because the pictures look the same size, honestly. Okay, let's look at part B. Part B says a triangle with angles measuring 60 and 70 and a non-included side. Okay, so we're going to have a triangle of 60 and 70, and the non-included side is 8. So if I were to look at this triangle I just drew, that base is the included side, and we do not want it to be 8. Okay, so in between 60 and 70, there should not be an 8. Let's check. In between 60 and 70, there's not an 8, not an 8, not an 8, not an 8. Okay, it did good. Okay, then it says 8 centimeters on a side of a 60-degree angle. That means across from the 8 is 60 degrees. So let's check our pictures. My bad, not across from the 8, on the 8 side should be a 60-degree angle. So, if I'm looking at this picture, 60 and 70, I need my 8 to be on the 60-degree angle. So that means I can either put it on the left or the bottom. But we know that non-included means we cannot use that piece in between the 60 and 70. So the 8 does not go down below. Instead, we're going to use this side that's connected to the 60. So when it says a side of 8 centimeters on a side of the 60-degree angle, that means you look for your 60-degree angle. There he is. And he has 2 sides, this top and this bottom. Well, it can't be the bottom because that's included. So it has to be this top left. Okay, let's check our pictures to see which one is true. My 8. Yep. It's this one on the left. Yeah. This one on B would be correct if it was 8 on that side of the 60. Yeah. Okay, C would be correct if this 70 was the biggest angle and 60 was the smallest angle. You can't tell, but this 70-degree angle, his line drops down lower than this 60-degree angle, and that's not how it's supposed to be. The lower angle drops down lower while the higher angle drops down higher. Okay, anyway. Okay, and then if we look at part D, it looks like we need the 8 to be on the side of the 60. So here's the side of the 60, and 8 needs to be on that side. So that's why D's out. Alright, so A. Alright, let's look at C. It says a triangle with angles measuring 30, 70, 80. Okay, so we need a 30, 70, 80 triangle. And all these look like they have those numbers in them. Okay, but what's the smallest angle? 30? Okay, well that means across from 30 should be my smallest side. Let's look at A. Across from 30 should be my smallest side. Yeah, and the bottom of that triangle is the smallest side. So A looks good. C looks good because across from that 30 is the shortest side. So across from the smallest angle is the smallest side. Okay, and then B and C, or B and D, that shortest side is across from the 80. That's the biggest angle. That's wrong. And on D, that shortest side is across from the 70. And that's wrong. Okay, so the shortest side should have the shortest angle, smallest angle. The biggest side, which in this case is 80, should have the biggest angle. As in, if I'm looking at a triangle, 80, the side for 80 should rise up as less steep, and our 70 should fall farther below. So the tilt of our 80 degrees should be almost up and down. The tilt of our 70 degrees should be the 80 but slightly below. Okay, so let's check it. It's kind of hard to tell. Let's see here. My 70 is supposed to be the smaller angle. If you look at A, it looks like 70 rises like that, and 80 rises lower. That's lower. And remember, this 80 degrees should be the bigger angle, as in it should be wider. If this 80 degrees went up like this, then yeah, that would be the correct answer, because our 80 degrees the tilt is less steep, or the angle is wider, it opens up wider. Okay, so if you look, so A's out, so C's in, because angle A is wider than angle whatever this is. So that 80 is wider than that 70. Okay, let's keep looking. Let's look at triangle congruency. We kind of talked about this in the last section. Remember, side angle side means two sides are congruent. They're the same. And the angle in between is also congruent, or the same. So that makes SAS. Yeah, okay. Where the A is included in between the sides. Okay, then there's another congruency that says, okay, if these sides of the triangle are the same, and these diagonals are the same, like equal, and these bases are the same or equal, it's called a S. Okay, then we have an ASA. That means two angles with a side included, because the letter S is in between. AAS means two angles, so two angles are the same or congruent, so these base angles are equal or congruent. These top angles are equal or congruent. And then a side that's not included is equal. If I was talking about the included side, I'd be talking about this diagonal piece, but this side below is not included in between those angles. Okay, and then the last thing is SSA is not sufficient for congruency. So side angle does not mean you have congruent triangles. Okay, so let's look at this homework problem. You're only going to have one of these pictures, but I went and did all the possibilities so everybody would know. Okay, you're going to have a homework problem that says, tell whether the triangles created are congruent and why. And we either say the SSS, the ASA, the SAS, or that they're not necessarily congruent. Okay, so first let's look at this first triangle. Okay, it looks like one big triangle, but if we split it up into two triangles, let's see what we got here. Well, we know that this little box is a right angle. Okay? And since we know it's a right angle on the right, we know that the left beside of it is whatever 180 minus 90 is. And that's 90 degrees. So both of these angles are both 90 degrees. Yeah. Okay. Then we know that this top two angles are the same. Okay, so far we got an angle and an angle. So SSS postulate is out because we don't have two A's listed there. Okay, now since these two triangles shared the same side, that means those sides are equal. Okay, the question is, are these sides in between the angles or not in between the angles? So are we going to have ASA or SAS? Well, we have angle, side, angle. So these two triangles will have the same two 90 degrees, the same two top angles, I don't know what they are, and the same length of this up and down, the height. So, since that side is in between the angles, it's angle, side, angle. Yay! Okay, and it's not SAS because they didn't give us two sides that were equal. Alright, let's look at this sucker. We got... Ooh, this is going to be a rough one. Okay, we got these two triangles, and it looks like they both have 90s. Both have 90s, so those are equal. Then there's this little at the A and the C, so those angles are equal. Okay, and then, yeah, that's it. They don't share the same of anything. If they were smashed up next to each other, then they would share the same side and would have an equal side. But these two triangles are not smashed up to each other. They're not sharing the same side. So there's nothing here that tells me there's another side that is equal. There's nothing that tells me another angle is equal. So let's see here. If it was SSS, they would have said all three sides are equal. They said nothing about the sides. ASA, again, we have the two angles, but we don't know that these two sides of the triangle are equal. The only reason we knew it on the last picture was because those two triangles were squished up together, as in they had the same height. Okay, so it's not ASA because we don't know what the lengths of these sides are. Okay, the last is SAS. Well, again, they didn't give us two sides that are the same. So it's nothing. Yeah. Okay, let's look at this next picture. They're already drawn for us. We got two triangles. Looks like they got one base angle the same, equal. Then they have a 90-degree angle, equal. But the question is, are these bases equal? And the answer is no. They're only equal if those triangles were squished up together. That's when they share the same side. These do not share the same side. So it's nothing. Okay, let's look at this next sucker. Okay, oh, they're squished. Okay, well, let's take out those two triangles and... Alright, looks like on these two triangles, they have these two corner angles the same. Okay, these two triangles have 90s. So 90s, those are the same. And then we share the same side. The only question is this side included or not included? Okay, well, if the side I was talking about was included, I would be talking about the side in between the two angles, but we're not. We're talking about this up and down. This is not included. So out of our three options, SSS, SAS, ASA, okay, well, we only have one side that's the same, so anything with more than one S is gone. Okay, and then I think on this specific triangle, they introduced something else called the AAS. Yeah, so far we haven't had to use this special AAS, but we're about to. So this is not SASA because the side that's equal is not in between my two angles, so it's not ASA. So that means it's angle, angle, side, because the side is not in between the two angles. And that only happens on this type of triangle and the one below it. Okay, the one below it, if we look, we have these two base angles are the same. We share the same side of a triangle, this height, this up and down, okay? And then it looks like we got a 90-degree angle on the right. Well, that means on the left, we have to have a 90-degree angle because lines make up 180 degrees. Okay, so we have angle, angle, and there's a side. Our question is that side in between the angles? Well, here's one of the triangles, that left-hand triangle. The side that we share, is it included or not included? If it was included, it would be the one on the bottom. So ours is not included. So that means out of ASA, AAS, SSS, and SAS, we're not going to pick anything that has more than one S. So goodbye triple S, goodbye SAS. And we're going to choose where the S is not in between the two A's. So AAS. Woohoo! Alright, let's keep going. Next, sort of the same thing, only we use different symbols. Okay, it says our, it looks like a Star Trek. Our angle BAD, let me draw it. BAD. Okay, BAD. Okay, so it's asking, is this angle and BCD congruent? Where's BCD? BCD. Okay, well, why don't we make a triangle? Yeah. Let's talk about the two triangles we have. Okay, so these two triangles have the same, see this double tick mark? That means they have the same long side. Okay, yeah. Okay, then these two triangles have, see this single tick mark? The same base. Okay, okay. Then, because these two triangles are squished up next to each other, they share the same side. Remember these triangles? They shared the same side. These did not share the same side because when you squished them up, the sides didn't touch. The only other triangles that shared the same side were these two suckers and these two. Okay? These two triangles, they share the same side. So that means that we have, let's see, okay, we have SSS. So the question was, are these two triangles congruent? And the answer is heck fire, yes they are, because we got SSS. So let's look for something that says heck fire yes and SSS. Part A says something about not. Well, that's not the answer. Part B says something about not. Well, that's not the answer. Part D says something about, yeah, they are, but it only talks about one set of sides, two set of sides. So part B says that they are congruent, but only because two congruent sides. But when we drew our picture, we saw that we had three congruent sides. So D's out because they gave us a pair of two. And we need a pair of 1, 2, 3, 3. Okay, part C is the answer because it says they are congruent because get SAS. Yeah. So look for the word R, A-R-E, and SSS. Alright, let's look at this sucker. Alright. It says, given ABC and DEC with congruent parts as marked, what else is needed to show congruence? Okay, well, let's trace. It looks like this top angle is the same. It looks like these double tick marked angles at the bottom are the same. Okay. And it says, what else is needed to show congruence? Okay, well, to be congruent, we either have SSS, AAS, ASA, or what's the one I'm missing? SAS. Okay, well, we got two angles. So let me scratch out anything without two angles. Goodbye SAS and goodbye SSS. Okay. So the only way we can be congruent now is if the side in between these two angles is equal. What's that side in between the two? Let's see. In between these two angles is like DE and AB. Yeah? Okay. And if that happens, if those are equal, then we have angle, side included, angle. So that's what this first sentence says. If AB is congruent to DE, then the two triangles are congruent by ASA. Okay, well, what about if we want to do AAS? Okay, well, there's two AASs we could have. We could have angle, angle, this crookedy side, or we could have angle, angle in this base. Let's look what letters they're talking about, okay? First, they talked about BC. Which one's BC? BC. It's the crookedy piece. So that means this crookedy piece has to be the same as the right-hand crookedy piece. So BC and what's this? EC. Hey, that's where we got this. Okay. Or it could be AAS if we have this bottom side congruent. And that's AC and DC. Now notice how they wrote that. AC, because they took the angle on the outside, A, to the point on the inside, C. Then when they wrote it for this right-hand triangle, they took the angle on the outside, D, to the angle on the inside, C. So make sure you write DC. Okay, so it says, how would we need to show congruence? Well, one of the sides needs to be equal from one triangle to the other. Okay, let's look at this next sucker. It says, construct quadrilaterals having exactly 1, 2, or 4 right angles. Which of the following shapes is a quadrilateral with one angle? Okay, when I read this, I thought, oh no, this is going to be a hard problem, but it's not. Quadrilateral means 4 sides. So, which picture does not have 4 sides? 1, 2, 3. D's out. 1, 2, 3, 4. C's in. B. 1, 2, 3, 4. B's in. 1, 2, 3, 4, 5. A's out. Okay, so quadrilateral means 4 sides. Then it says exactly 1 right angle. Well, B has 1, 2, so B's out. Hey, C's the answer. And as you keep going, it's not crazy. Count, look for the amount of sides, then look for the amount of right angles. You'll be able to do it. Okay, on an isosceles trapezoid, the 2 angles at the top are congruent, and the 2 angles at the bottom are congruent. They're called base angles. So these bottom 2 are equal, these top 2 are equal. Okay, let's keep going. It says, what type of figure is formed by joining the midpoints of a rectangle? See the figure to the right. Okay, so the midpoints of the rectangle are the middles of the sides, and it's asking, what picture do I make? Okay, well, first let's see if any of these sides are equal. Okay, so if we're looking at this picture, let's say, if we're looking at this picture, we're looking at this triangle. This triangle has the same, or let's say I'm looking at these 2 triangles. My bad, these 2 triangles. These 2 triangles have the same length top piece. They have the same length height. So far that's a S and a S. And then because it's a rectangle, all rectangles have 90 degrees. So that means this angle in between is also congruent. So this means of these 2 little triangles, we are given a side, an angle in between, and then another side. That's SAS. So because of SAS congruence, that means that these 2 triangles are congruent, as in equal. And if they're equal, that means they share the same hypotenuse, this diagonal. So all these diagonals should be equal to each other. And the reason that they're equal to each other is because in these original 2 triangles, The two sides were equal because of the tick marks and the double tick mark. Then we knew a rectangle has 90 degrees in it, so the two angles are equal. So that means these two triangles are congruent by SAS, meaning this diagonal is going to be the same length. So since they share the same lengths, so this diagonal of the triangle is equal to this diagonal over on the right triangle, equal to the diagonal of the bottom triangle, equal to the diagonal of this left triangle. So that means we have this shape and all the sides are equal. So, if we look over here on the left, it says that a rhombus has all four sides equal. Yep, it's true. So, this picture became a rhombus. So this little diamond looking thing, since it's equal on all four sides, it's a rhombus. Yay!